Greetings! In today's lesson, we will explore how to determine the coordinates of specific points, where the graph of the function crosses the coordinate axis. We are dealing with two axes, the x-axis and the y-axis. And we need to find and write down the coordinates of these points. We can use a graphing method, which entails drawing the graph of this function and locate those points where the graph of the linear function intersects our coordinate axis. Let's take advantage of this method. We have a linear function written down and we need to plot its graph. Well, for this, we assign a value to the variable x and determine the corresponding y value. Rather than x, I will put down a value equal to -2. What will the result be? 3 multiplied by -2 is -6. -6 plus 2 equals -4. So the value of y will be -4. Let's substitute another value for x, which is -1. 3 times -1 results in -3. Adding 2 gives us -1. Therefore, we can plot the graph of the linear function. Let's find these points on the coordinate plane. The first point is -2, -4. -2 along the x-axis and 4 along the y-axis. As a result, the point with coordinates -2 and -4, we marked it. The next point has coordinates -1 and -1. Here is that point. Now, we will draw a line connecting these 2 points. What will we get as a result? What did we find? The graph representing our function crosses the y-axis at the point with coordinates 0 and 2. It also crosses the x-axis at the next point. We need to find its coordinates. We see that the coordinate of this point on the y-axis is 0. How do we find the x-coordinate? Perhaps it is -1/4. It might be -1/3. How can we find this coordinate? If the function's graph intersects the point where we can definitely find this coordinate, we write it down. But when we encounter a situation where it's challenging to find the coordinate, particularly the x-coordinate, then we can use the algebraic method. Let's avoid writing the coordinates of the intersection point with the y-axis, but check this coordinate instead. Yet, let's write down that our line crosses the y-axis at the point with coordinates 0 and 2. We easily found this point, but we haven't identified the intersection with the y-axis. However, we know that along the y-axis, the y-coordinate is not 0, and we need to find it on the x-axis. How do we find this coordinate without graphing the function? For this situation, we should follow this rule. I want to draw your attention to the coordinates. When our line or the graph of any function intersects the y-axis, the x-coordinate is equal to 0. We determined this by graphing the function. When our function's graph crosses the y-axis, y equals 0. We will use this for the algebraic method. Let's write it. When our function graph intersects, it shows the intersection, the y-axis. Remember, we have 2 axes, x and y. When it crosses the y-axis, then x will equal 0. and we must substitute this value into our function and find y equals, which we had written as 3x plus 2. I will put 0 in place of x, since this is the condition, and thus y equals 2. Let's note this coordinate as 0, and we got the y value as 2. Let's check it. Point. This point's coordinates are 0, 2. We found it by graphing, but in this case we found it using the algebraic method. Now, let's find the coordinates of the intersection with the x-axis. If the function's graph crosses the x-axis, then the second coordinate is equal to 0. In our case, y equals 0. So what do we end up with? In our function, where y is equal to 3 times x plus 2, we replace y with 0. First, we put 0 in for x, then we did the same for y. As a result, we will determine the value of x, which is what we need to find. What do we find? 3 times x equals negative 2, leading to x being negative 2/3. And this is the value of x that we could not determine from our function's graph. Therefore, this point with coordinates, let's write down minus 2/3 and 0. Let's conclude. If we need to determine the coordinates of the intersection point with the axis with the y-axis, we substitute 0 for x. If with the x-axis, then y is 0. You can find these coordinates without graphing the function. In the next lesson, we will solve the task and determine the coordinates of the intersection point of the function's graph with the coordinate axis. Today's lesson has concluded. Goodbye until next time.